Hi, my name is Max Columbada.
And my name is Timothy Wagner.
We are part of the IB Simplified 101 channel, and today we're going to be covering the second part of Unit 2 of the Math Analysis and Approaches Standard Level course. The units covered in the first semester of this course are Unit 1, Unit 2, and Unit 3. Within the second part of the second unit, Unit 2b, domain, range, rational functions, composite, and inverse functions, inverses of functions, and absolute value functions can be seen. And all of these concepts are going to be analyzed within this video. Quick disclaimer. All the information shared within this course in the IB Simplified 101 channel is strictly and specifically for review or as introductory content. Do not use the following information as a way to properly learn the concepts, as you should do this in class. This is just for review. Also, we didn't extract the following information from a textbook, since the class doesn't rely on one specific textbook to teach you all the concepts throughout the class compared to a class like IB Biology. So most of the information extracted in this video is either from previous knowledge or uh, online sources.
Domain and range. So the domain of a function are all the possible inputs for the function, specifically for the x values. And then range is all the possible outputs for the y values. Um, as you can see, domain is more of the horizontal aspect, and then range is the vertical aspect. So that is domain and range.
When it comes to the notation of domain and range, there are a multitude of ways that you can demonstrate it. The following four ways are acceptable for IB exams or can be seen in IB exams. So, if you want to prepare accordingly, you should be able to interpret the four methods and learn one of these methods so that you can repeat across the entire course. There is a visual representation, a notation, and also a representation across or through words. You should be able to explain a certain domain or range across a variety of notations, whether it is a visual representation, as I said before, a notation representation, or through words. In the case that you have an asymptote in the notation, where values within um, a certain range, a certain point, simply do not exist, then you can use the following notation. So, for example, in this rational function, which we're going to cover later on, x can be all values except 2. So you can show the domain as x simply not being 2. And for the range, it would be the same.
Rational functions. So the parent function is 1 over x, and at its simplest form, x approaches 0 and y approaches infinity. X equals 0 and y equals 0 are values that are not in the domain or range, and these are the asymptotes. So these rational functions will never reach 0 or the center point of a graph, if you would view it that way.
The asymptotes of a rational function, as Timmy says, are the points where a value simply does not exist. You can think of this as, let's portray in the parent function of 1 over x as x being 0. So as we may know, if you divide any number by 0, at least if you put it in a calculator, you're not going to get a number. You can't really assess, you can't really calculate that. So there's no proper value that you can give to that input. When you want to graph these, it's surprisingly simple. Remember, this is just review. So or introductory content. So you should actually process this information after, or remember this information, and you should have already drawn a couple. So you should have some experience, or this should be your introduction to the process. So to graph properly, you need to outline exact asymptotes, but the actual curve doesn't have to be exact. So the curve does have to be accurate, but it doesn't have to be exact. The quadrants chosen also have to be correct, because if the x value is negative, then the quadrants are going to flip. As we saw in the parent function, the original quadrants are going to be the quadrant 1 and quadrant 3. So if we flip it, we're going to have quadrant 2 and quadrant 4. Other transformations may also flip the graph across different quadrants. If you want to find the asymptote so that you can outline it and graph it properly, then this is how you do it. If you want the vertical asymptote, which is basically all x values, the vertical asymptote, in that x value point, there's no actual output, then it's as simple as finding when f of x equals 0, right? So we can see that specifically in the denominator of the function. So in the example on the right, we can extract x squared minus 9. And in that case, 3 would be the vertical asymptote, since 3 squared equals 9, and 9 minus 9 equals 0. And then we get x over 0, and that would be an asymptote, since that is not a real number. You can't assess that number. For the horizontal asymptote, you can see the following guidelines also to the right, where if in the following equation, where you have f of x equals ax to the power of m over bx to the power of n, leading terms only, if in this case n over m, n is over m, n is bigger than m, then y, or the horizontal asymptote, is going to be 0. If m is bigger than n, then there is no horizontal asymptote. And if m equals n, then the horizontal asymptote is going to be a over b, or the coefficient. Here we have a couple of examples. If you want to solve these on your own, you can. We're not going to go through the process, but you can use the information we detailed in this video to solve the following problems. And here are the solutions. Now for composite functions. These functions use the output of one function as an input for another. Therefore, you will need two functions. This can be explained in the following formula, where if f of x equals y, y being the output, then for the following function, the g function, we're going to use y from the f of x function, the output of the f of x function, as an input. And so g of y is going to equal z, our output for the g function. And this is all going to combine into one composite function. There's going to be two main formats in which you can see this, either in exams, tests, or use on your own. I like calling the first one fog or goff, because normally you use either f as a function name or g, and you have a little circle in the middle, and you can see it's fog or goff. And the other one is the more straightforward one, where you can see g of x inside of the input of f, right? But the important part is, if we go back to the fog format, the function to the right of the circle, right? So we have fog and goff right there. the function to the right is the one that is being introduced to the left, right? So the one to the right always is being introduced into the one on the left. So if we see in the fog example, G is being introduced into F. And in the golf example, F is being introduced into G. To the right, we can see an example where they're going to provide you with the two functions. And then you can find a composite function that goes two ways, where we can both introduce f of x into g of x, right? The output of f of x into g of x, as in one of these examples. And then we can do it the other way around, where we get the output of g of x and use that same output in f of x.
Okay, so inverse functions. An inverse function is the operation that undoes the operation of f. So if f of x is equal to y, then its inverse will be f of y equals x. Inverses are written in the following manner: f to the power of negative 1 times x. So the inverse of f of x is written as f to the negative 1 of x.
So for the examples of inverse functions, we can see two problems. There are more problems that you might see or encounter, but these are the main ones that are going to be asked in quizzes and tests. So if this is introductory content for you, then learn this first, and then the other intricacies in class. And if you already learned the intricacies in class, then just use this as a review, just a disclaimer. So first, you may be asked to graph an inverse, and in that case, you just need to mirror it over the function, um, the function, the linear parent function, right? Where y equals x. So in the parent function, in the parent linear function where y equals x, if we input 1, we're going to get 1. If we input 2, we're going to get a 2. So it's going to linearly be just 1. The gradient is just going to be 1. So if you're asked to graph an inverse, then graph the original function, then graph the dotted line through the middle, as you can see in the left graph, the dotted parent function of a linear function, and then mirror it over that one, and you're going to be able to successfully graph an inverse. The other type of problem would be where you have to rewrite an inverse. And here you need to do 3 steps. Step 1, you rewrite f of x as y equals, right? So then you swap the x and the y, and then finally you solve for y. Here we have a following example of that procedure. So in the case that we want to rewrite an inverse, the following example can explain it successfully. Let's say we have f of x equals 3x plus 2. Pretty simple function, right? Let's follow the steps that were outlined before. So first, we turn the function, the f of x, into the output, into y, right? So let's say the output is y. So now we have y equals 3x plus 2. Now let's swap y and x. This is the next step. So now we have x equals 3y plus 2. Y is now our input of the inverse function, and y is our output. So we need to leave the y alone in one of the sides. So then we do minus 2, so we get to x minus 2 equals 3y, and then we divide both sides by 3. So we end up with x minus 2 parentheses divided by 3 equals y. So the inverse of f of x being 3x plus 2, the inverse is going to be parentheses x minus 2 divided by 3.
Absolute values. They're a non-negative value of x without regards to sign. So it's denoted with these two lines. So 3 and negative 3 have the same absolute value because absolute value measures the distance from 0 regardless of whether it's negative or positive. An absolute value function, as seen right here.
Thank you for watching. This was the IB Simplified 101 channel. Yet again, the disclaimer. Use this information as introductory content or review. Thank you for watching, and I hope you guys look forward to our following math videos, biology videos, and economy videos. Thank you.